Welcome back. This is section 6.1, which is about standard deviations and normal distributions. So let's go ahead and take a look at what the first objective is. The first objective is to understand the notation and interpret the parameters of a normal distribution. So let's go ahead and start with what is a normal distribution? What does it mean by normal distribution? A normal distribution is often described as a bell-shaped curve with the parameters mean and standard deviation. It's also known as Gaussian distribution. So majority of the data that we take in statistic, when you graph them as a histogram, that falls as a bell-shaped curve, that falls under a bell-shaped curve. So that's why we say that majority of the data is normally distributed, which is also a bell-shaped curve, which is also a Gaussian distribution. The two important factors of a normal distribution are the mean and the standard deviation. Now let's go ahead and take a look at what is a standard deviation. We know what a mean is, it's the average, right? But what is a standard deviation? The word deviation should give you some kind of hint along with the word standard. So when I'm saying deviation and I'm saying standard, that means I am deviating at a standard rate. But you might ask, Miss, what are you deviating from? Deviating from the mean. So standard deviation is nothing but the data values or the probability distributions deviating from the mean value. And how do you represent standard deviation? You represent by a Greek letter called sigma. Now let's go ahead and take a look at the problem here. The graph below shows three several normal distributions. So I have A, I have B, and I have C, right? And what are they asking me? They're asking me which one has the largest standard deviation. Now, let me go ahead and talk a little bit about how to look at this one. Let's just say I am a standard deviation, sorry, I am a mean, and I have my data values very close to me. So if I have to touch my data values, imagine how much I am spreading my hands. So I have all my data values right next to me. I don't have to spread my hands, right? I can touch them from right here. But what if my data values are spread out? I have to spread my hands to touch them. So what am I doing? I am stretching the curve. So the further you stretch the curve, that means the larger that they are deviating from the mean. So here, when I look at it, definitely not B because it's very close to the mean. I have to pick from C and A. And as you can see, A is much more spread out than C. So A has a larger standard deviation and not C. Now let's go ahead and take a look at the next one. Given the plot of normal distribution A and B below, which of the following statements is true? Select all correct answers. Now let me go ahead and take a look. So I have my curve A and I have my curve B. Very good. As you can see, A is much more spread out. So I know A has a larger standard deviation. But look at B. B is on the right hand side of the A. That means the mean value or the average value of B is greater than the average value of A. So B has a larger mean. There you go. B has a larger mean and A has a larger standard deviation. All right. Now let's go ahead and look at what we have next. All right. So here we're going to go ahead and recap what we talked about normal distribution. So normal distribution is a continuous distribution. Let me move my mouse right here. Normal distribution is a continuous distribution, most important and widely used distributions in statistics. So majority of the data that we take is normally distributed. The graph of normal distribution is sometimes called a bell curve because it depicts a bell shape. And it's also called the Gaussian curve, named after the scientist the mathematician, who played an important role in discovering this particular distribution. All right. And because it is a distribution of a continuous variable, continuous random variable, we always talk in terms of area and probability. Remember, probability is nothing but your area under the curve. Area under the curve is nothing but your probability. So when you add all your probabilities, you should get a 1. So when you add the area, or the total area under the curve should be equal to 1. That's how you always remember. The area under the curve is 1. Now, as you can see, you have a normal distribution and you have a standard normal distribution. So what's the difference between normal? What's the difference between normal distribution and a standard normal distribution? So a normal distribution is where the mean can be anything. Mean can be 10, 5, 6, 100, million. But in a standard normal distribution, my mean is always equal to a 0 and my standard deviation is always equal to a 1. All right? So the difference between normal distribution and standard normal distribution is the mean of a normal distribution can be anything, but the mean of a standard normal distribution is always a 0. So the mean is always 0 and the standard deviation is 1. All right, let's look at the 7 features of normal distribution. Most importantly, it's symmetric around its mean. That means when I cut that in half, it's exactly equal on both sides. The mean is equal to the median is equal to the mode. Total area under the curve is 1. It's denser in the center and less denser in the tail. So as you can see, I have my entire data accumulated in the center, and as I go towards the tails, the data becomes less and less denser, because usually majority of the data is very close to the average until unless they are outliers. All right, normal distribution has 2 parameters, most important parameters, your mean and your standard deviation. 68% of the data, 68% of the area of normal distribution is within 1 standard deviation, and 95% is between 2 standard deviations. We're going to talk about this in a minute, but for as of now, this is what it is. So standard normal distribution, remember standard normal distributions are standardized values called z-scores, which are measured in units of standard deviation, having a mean of 0 and standard deviation 1. So what does it mean? So to find the standard deviation, I always use something called a z-score. So I use my z-score. So z-scores are like a measurement. So if I ask you how many miles are you from school, you will tell me 12 miles, 7 miles, 8 miles, right? So z-score is a distance in terms of standard deviation. So if my z-score is 1, that means I'm 1 standard deviation away. If my z-score is 2, that means I'm 2 standard deviations away. There is a formula to find the z-score, which we will be looking in a minute. Normal distribution is also referred as Gaussian distribution. We saw that. It's denoted by the Greek letter sigma. So let's go ahead and take a look at what the next one is, okay? We're going to be talking about standard normal distribution. So all distributions do not necessarily have the same mean or the standard deviations. There are like millions of distributions, millions of data values that I take. Every data has a different mean, different standard deviation. We standardize all normal distributions so that every distribution has a mean 0 and has a standard deviation 1. And that is called a standard normal distribution. Again, let me repeat, because we have so many different data sets and every data set has a different mean and standard deviation, we standardize all these data sets, and that's called a standard normal distribution. And we use something called a z-score to standardize these distributions. So let's go ahead and take a look of how to represent a standard normal distribution. A standard normal distribution is represented as z tilde n mu and standard deviation. So we're going to talk about that in a minute. So let me go ahead and erase this. All right, so here we have a standard normal distribution is a normal distribution of standardized values called z-scores. A z-score is measured in units of standard deviation. So if x is normally distributed, random variable x tilde n, open parentheses, mu, standard deviation, close parentheses, then z-score is. Okay, so it makes much more sense when we start working on the problems. But for now, you have to remember the formula of the z-score, which is x minus mu over the standard deviation, where x is the data value. All right, now let's go ahead. Remember what I talked about z-scores. Z-scores will tell you, z-scores are the distance given to you in terms of standard deviation. If I tell you my z-score is 1, so that means I'm 1 standard deviation away. So here I have my normal curve and here is my mean 0. So when I look at it, this is my standard deviation 1. This is 2 standard deviations, 3 standard deviations. And this is 1 standard deviation below because of the negative sign. This is 2 standard deviations below because of the negative sign. 3 standard deviations below because of the negative sign. So what I'm saying is when the z-score is positive, that means your value is greater than mean. So this is the mean. And if you're positive, you're on the right-hand side. If you're greater than the mean, you're on the right-hand side. If you're less than the mean, you're on the left-hand side. Again, keep in mind, z-score is the number of standard deviations you are away from the mean. So if your z-score is negative, that means you're below the mean. If your z-score is 0, that means you're equal to the mean. So let's go ahead and take a look. And again, keep in mind, 68% of the data lies between 1 standard deviation, 95% of the data lies between 2 standard deviations. Are you ready to do some problems? All right. So here I have my first problem. It says suppose x with tilde n 17.6 and x is equal to 5. Find and interpret z-score of the standard random variable, standardized normal random variable. So what does that mean? What is it telling me? So what they're asking me is they're asking me to interpret my z-score. They're asking me to interpret my z-score. So let me start with the formula. What is z-score? X minus mu over standard deviation. Oops, what was that? X minus mu over standard deviation, right? So now I have to find my z-score. So I start finding what my x is. My x is equal to 5. I need to find my mu. I need to find my standard deviation. According to the formula, the first value is your mu. The second value is your standard deviation. Mu is my mean. My mean is 17. Standard deviation is 6. So I'm going to go ahead and plug this in. 5, which is my x, minus mu, which is 17, over standard deviation 6. So I have 5 minus 17, which is negative 12 over 6, which is negative 2. So my z-score is negative 2. So let's go ahead and take a look on what exactly, okay. So let's go ahead and take a look what exactly this means that my z-score is negative 2. So let me draw a number line here. My mean is 17. So that means this is 16, this is 15, this is 14, right? So let's go ahead and take a look what exactly does this mean. So this is my number line. This is my mean 17. My standard deviation is 6. So if I have to move 1 standard deviation, that means I'm moving 6 units. If I'm moving 2 standard deviations, I'm moving 12 units. 1 standard deviation from 17 is 17 plus 6, which is 23. 23 plus 6 is 29. Now, if I have to move on the left-hand side, 17 minus 6 is 11. 11 minus 6 is 5. So as you can see, the value 5 is 2 standard deviations below the mean. That's exactly what we got. -2. So this -2 is telling me that this value 5 is 2 standard deviations below. So the negative value tells you it is below, and the positive value tells you it is above. So just by comparing the numbers, my x is 5 and my mu is 17, I know my z-score has to be negative because 5 is less than 17. Now let's go ahead and take a look at the next problem. And let me erase this. All right, in 2014, the CDC estimated that the mean height of adult women in US was 64 inches. So the mean height. So I write as I read. The mean height is 64 and the standard deviation, right away, my standard deviation is 4 inches. Suppose X, the height in inches of adult women, follow the normal distribution. Usually the heights do follow normal distribution. Majority of the heights are normally distributed. So here I have X value. So I have my X value is equal to 68. And the height of a woman who is 5'8" tall, find the z-score of standard normal random variable. So when they say 5 feet and 8 inches, that means she's 68 inches tall. All right, even before we look at z-score, tell me this is your mean, right? This is your mean and this is your x value. So are you above the mean or below the mean? So definitely 68 is above the mean. So I know my z-score has to be positive. All right, so let's go ahead and calculate the z-score. What does z-score stand for? X minus mu over standard deviation. My x value is 68. My mu is 64. Standard deviation is 4. 68 minus 64 is 4 over 4 is 1. So my z-score is 1. That means I am 1 standard deviation above the mean. How do I know it's above? Because of the plus sign. And just by looking at the numbers, 68 is more than 64, so I am above the mean. All right. Let's look at the next problem here. I'm just going to move this. All right, so John averages 58 words per minute on a typing test and a standard deviation of 11 words per minute. So as soon as I see something, I write it down. So I'm going to use, let's just say, what color pen should I take? I'm going to take, all right. Oh God, I'm going to take a red pen. Okay, so my average is 58, as you can see, and the standard deviation is 11. Okay, so I'm going to write that down. Average is 58 and standard deviation is 11. Suppose John's words per minute on a typing test are normally distributed. So if it's not normally distributed, I cannot use my z-score. Please keep that in mind. Let x equal to the number of words per minute on a typing test. So they said then x tilde n 58 11. That means 58 is the mean, 11 is the standard deviation. Suppose John types 72 words per minute in a typing test on Sunday. The z-score. The mean is 58 and my friend John here typed 72. So you tell me, will he be above the mean or below the mean? Definitely above, right? If he's above, that means z-score has to be positive. All right. Let's go ahead and take a look. Z-score is x minus mu over standard deviation, which is, where is my x? 72 minus 58 over my standard deviation is 11. All right, so 72 minus 58. I end up with 14 over 11. Right? When I round it off, I get 1.27. So what does that tell me? Definitely it's positive. So here it says the z-score is 1.27 and the mean is 58 because that's what the mean is. So the z-score tells you that x is equal to 72 is 1.27 standard deviations to the right of the mean. By default, if you are greater than the mean, you are on the right hand side. If you're less than the mean, you're on the left hand side. All right. And if you're on the left hand side, your z-score is negative. If you're on the right hand side, your z-score is positive. Perfect. All right, let's look at the next part here. Calculate the mean and standard deviation of the normal distribution. So they're asking us to go backward. Always make sure you start with the formula. Z is equal to x minus mu over standard. What's happening? X minus mu over standard deviation. Let's go ahead and read the example. They're asking us to find the mean. Floretta's points per basketball game are normally distributed with a standard deviation. So as soon as they say something, I'm going to write it down. Standard deviation is 4. And Floretta scores 10 points, okay? So the x value is 10. And the z-score of this value is negative 4. Ooh, just by looking at the z-score, which is negative 4, I know Floretta scored way below. Okay, then what is her mean points in average game? All right, so I have the z-score, which is negative 4. I have the x value, which is 10. I do not have the mean, which is mu. I do have the standard deviation, which is 4. To find the x value, I simply cross multiply. So negative 4 times positive 4 is negative 16 is equal to 10 minus mu, right? I subtract 10 from both sides. What do I end up with? Negative 26 is equal to negative mu. That means mu is equal to 26. Please don't say it's negative 26 because you don't make negative 26 points in a basketball game. So your answer is positive 26. So on the average, Floretta makes 26 points, but that day she scored 10 points. That means she scored way below her regular or the average points that she scores. Usually in NFL game, when they draft a player, they get paid so much, not because you like the player or you like the team. It's because they always calculate the average and they always calculate the standard deviation. Your standard deviation has to be very, very small. That means you know what's coming. If a player usually, let's say a kicker hits 64 yards per when he kicks and his deviation is 10, that means you're telling me he can hit anywhere from 54, which is way below. So you don't want that huge deviation. You want to be very close to the average so you are predictable. All right, let's go ahead and take a look at the next problem here. Find the standard deviation. In the previous question they said mean. Now they're asking us standard deviation. Again, I start with my z-score. Z is equal to x minus mu, over standard deviation. Karen scores 18 points on a game. Karen scores an average of 18 points. So I know the mu is 18. And her points per game are normally distributed, of course, because we are trying to use the z-score. Suppose Karen scores 12 points in a game. Okay. And this has a z-score of negative 3. Okay, so I want you to pause for a minute before we calculate the standard deviation. Karen usually scores 18 points, and today she scored 12 points. So that is below, definitely below. But they're saying it's negative 3. That means it's way below. When it's so below, that means the standard deviation is very small. Let's go ahead and take a look. I'm going to go ahead and plug in the values. My z value is negative 3. My x value is 12. My mean is 18. Standard deviation, I don't know. So I have negative 3 is equal to 12 minus 18 is negative 6 over standard deviation. So I'm simply going to cross multiply. Negative 3 times standard deviation is negative 6. Divide both sides with negative 3. So my standard deviation is positive 2. You cannot get a negative answer because your standard deviation always has to be positive. So please keep that in mind. And even if I did not do all this, negative 6 over what gives you negative 3? Positive 2, right? So my standard deviation is positive 2. So let me go ahead and use a different color so I can show you. This is Karen. Her average is 18. So if I go one standard deviation above, I will make a 20 or she will make a 20. If I go another standard deviation above, she will make a 22. If she goes below, she will make a 16. If she goes one more below, she will make a 14. If she goes one more below, she will make a 12. So she went 3 standard deviations below to make a 12. See how it all makes sense? I hope this video helps. Again, if you have any questions, please make sure you email me or contact me through Teams.